Okay, now, so having said that, if you look at this Cramer's rule here, what can you notice about the formulas? You can discover that, or you can see that we have determinant of A common at the denominators, and then the difference is just their numerators having A, X, A, Y, and A, Z. So the question now is, what does this A and all these A, X, A, Y, A, Z stands for? What do they stand for? That may be the question you'll be asking. So let's see how to get them. Let's start with this common one, the denominator. You can see we have determinant of A. So let's start. What does determinant of A, what does it really mean, or what does it stand for? Now, this is what your determinant of A stands for. It is all the coefficients of the variables. So the determinant of these coefficients, that is our A. So let's look at the coefficients of X. We have 3 minus 6, 9. 3 minus 6, 9. So that occupies the first row. Let's look at the coefficients of Y. 1, 5 minus 2. 1, 5 minus 2. Let's look at the coefficient of Z. 1, 3 minus 1. 1, 3 minus 1. So this is the determinant of A. So determinant of A is just the coefficients or the variables. So take note that the first row represents the coefficient of X, the middle row represents the coefficient of Y, and then the third row represents the coefficient of Z. So, like as I said, anytime you see two strokes like this on arrays of numbers, it means determinants. So it's either you use your Cyrus rule to solve it, or you use your expansion by minus method. So to get our A, we are going to use our Cyrus rule. I prefer the Cyrus rule. If you prefer the other method, you can go ahead to do that. Now let's apply the Cyrus rule to this. Can we recall the Cyrus rule? The Cyrus rule says that all we have to do is to do what? Is to add the first two columns. So I'm going to add this. I'm going to add 3 minus 6, 9. I've added this first. I'll add the second one now. 1, 5, and minus 2. So when you add them to these arrays of numbers, all you have to do next is to find their major diagonal. So this is the major diagonal. The major diagonal is always in 3 forms. These 3 diagonals. These are major diagonals. And then we get also the minor. So the major diagonals, let's times them out. Let's see what's going to give us. 3 times 5 times this. This will give me 3 times 5, 15. This will give me minus 15. Okay, and then if you do this other one, it's going to give me this times this, 27. If you also do this, 1 times minus 6 times minus 2, that will give me 12. Okay, and when you sum up everything here is going to give us 24. Remember, if you sum them up, this will give us 24. Hope you can see that. Okay, 24. Now I'm going to do the same thing for the minor diagonal. The minor diagonal is this way. Okay, so let's get those ones this way. I'm going to mark out 3 also. Let's get these 3, this. We have this, and then we have this. So let's time them out, the 3. So let's go. We have 1 times minus 6 times minus 1. Okay, 1 times minus 6 times minus 1. That will give me plus 6. We have 1 times 5 times, sorry, 3 times 3, 9 times this, that's minus 18. And then we have this times this, which is 45. Let me clean this a little bit so I can have space. So if you also sum up everything here, that gives us that is going to give us 33. If you sum up everything here, that gives us 33. Okay, now we have gotten the major diagonal. Remember that these are major diagonal, these are minor. Please, we have done this before, so it shouldn't be an issue. So which means that our A determinant is major minus minor, and that is 24 minus 33. So our answer is minus 9. So that is my A determinant. I've gotten my A determinant as minus 9. So we are going to we have gotten this now. So we have gotten minus 9 or 2 as our denominators. So what is left for us to get now is my AX, AY, and AZ. So in my next video, I'm going to show you how to get those other ones. Thanks for watching. Have a good day.